Before we understand Spark lazy evaluation, let's recall on how normally a piece of code is executed. In this Python code snippet, the user is prompted to enter two numbers, and we perform some basic math operation on them. Let's say we give number 1 as 6 and number 2 as 2. If you see in the debug console, as soon as the execution hits a particular line of code, the operation is executed. However, this is not the case with Spark execution. In Spark execution, operations on dataframe are categorized into transformations and actions. The transformations are lazily evaluated, that is, Spark will not execute the transformations until an action is called. So in transformation like map, filter, select, with column, group by, etc. are called, Spark will not execute them immediately. However, when we call actions like collect, show, count, etc., that's when it triggers the execution and gives us the result. To understand the concept of Spark lazy evaluation, let's take an example of the code snippet. First part of this code snippet creates a data frame with some sample data. In the second part, we have added some transformations using filter with column, and finally we call an action, count in this case. So, until count is called, the transformations are not going to be executed. If we construct the DAG representation of the code, it shows two major code flows. While Spark lazy evaluation helps in optimizing the execution by delaying the loading of the data frame and efficiently combine actions. However, the downside is the reevaluation of the common part till the data frame is filtered. To avoid those reevaluations, we can save the intermediate result using options like cache or persist as used in the example. Thank you for watching this video.